Hello everyone and welcome to Module 3. We are kicking off Module 3 with 3.1a lesson on Slope-Intercept form. All right, scoot this over a little bit. Okay. So let's first of all, you may have heard us talk about slope-intercept form before. Usually when we have an equation that is linear, we realize that it already is written in slope-intercept form. Okay, so in case you forgot, let's go ahead and just reintroduce it. Every equation that is linear, you ideally want to keep it in this form because it's easier to graph. Right away you'll see that the m value is your slope and then your b value is your y-intercept. I'm going to go ahead and just create an equation. Let's say y equals 2x plus 1. We know that that has a slope of 2 and a y-intercept of 1. And if I were to graph that, start at the y-intercept, 0, 1, go up 2 and over 1, up 2 and over 1. You can also go down 2 and left 1, down 2 and left 1, then just connect your line. Okay, so just really take note that m is always going to be your slope value and b is going to be your y-intercept, right? Your initial amount. Okay, let's keep going. So today's lesson is 4 pages long. I'm going to do my best to talk about most of the problems. Please follow along with me, and let's just get right to it. Directions: find the slope and y-intercept for the graph, table, or story. Write the equation of each line in slope-intercept form. Okay, so if we're given a table or if we're given a graph like this, what you're going to do is the first thing you want to identify is your y-intercept. Okay, ideally it is on a distinct point, and in this case it is. My y-intercept is at 0, 2. I'm just going to write that on the side. And then what you want to do is you want to find the next distinct point. Right? This graph is it's not very clear where the next distinct point is. Some graphs are more accurate than others. I'm going to go ahead and ballpark it at this point right here. It's not really the best graph, but I'm going to ballpark it right here. And at this point, it is at 6, 4. So now we know from Module 2 that we can calculate the slope algebraically by looking at the y change divided by the x change. But in this case, you can also just use your slope triangle rise of 2 and a run of 1, 2, 3, 4, 5, 6. That also makes the argument that 1/3, this point, is also a distinct line. So you kind of want to just see where the distinct points are, so then you can basically calculate your rise and your run. And again, in this case, I'm noticing that the m value is 1/3. I'm noticing that the b value is 0, 2. You should definitely get in the habit of writing your y-intercepts as a coordinate point. And then the equation is simply y equals 1/3 x plus 2. Right? 2 is your starting amount right there, and 1/3 is your slope. Okay, let's move to number 3. Number 3 is a horizontal line at 1, 2, 3, y equals -3. In this case, we know that horizontal lines have 0 slope, right? So I'm just going to put a slope of 0. The y-intercept is at 0, -3. And we know that because the slope is 0, really the x value here, right, it would be y equals 0x minus 3. But we also understand that the 0x is not even present, really, if it's 0 times x. So your final answer is just y equals -3. Okay? And I want you to write a little note for yourself. The note I want you to write is an isolated x, or an isolated y, I'm sorry, y equation is a horizontal line. Okay, when you have an isolated y like this, that already tells you that your graph will be a horizontal line. Now let's segue to number 5. What do you think this will look like then? Right? So this is not the same situation as number 3. In fact, this is when there is no run. We talked about this in module 2. When you have no run, we have an undefined slope, right? No run is basically when you have a vertical line. So our slope in this case is going to be undefined. Now, undefined graphs potentially may not have a y-intercept, right? Especially if your graph itself is not the y-axis. In this case, it's at x equals -1. So if I were to graph a sketch, it would look like this because it's all at -1. And you can see how this graph never really touches the y-axis. So does it have a y-intercept? The answer is none. It does not. And then the final thing you want to realize is if an isolated y equation is a horizontal line, then that means this, when you see all the x values being the same, you know that the equation is going to be x is equal to whatever this value is. X is equal to -1. Okay? And this is going to be a vertical line. Okay, so just make sure you understand the differences between number 3 and number 5. Again, recap, number 3 was a horizontal line, which means it's an isolated y value. And number 5 is a vertical line because all the x values were the same this time. Your slope is undefined. You don't have a b value, don't have a y-intercept, and then your equation is literally just the number that the x values are always. Right? Okay, so let's move on. A basset hound weighs 100 pounds and is on a special diet to lose 4 pounds per month. Go ahead and circle anytime you see a rate. If X represents the number of months passed and Y represents the weight of the dog, write an equation that represents this situation, right? So we could see that the 100 pounds is kind of like what the basset hound starts off as, the weight of the basset hound in the beginning, and he's trying to lose 4 pounds per month. So you know that losing weight is negative. So this is immediately -4x plus 100, right? Notice how the variables were already defined for us, so I'm not going to define it. But in case the variables were not defined, you should always say like x is equal to number of months, right? And y is equal to weight of dog. You always want to make it very, very clear what your variables stand for. Okay, let's do another one. Your cell phone plan has a flat rate of $30 each month. Go ahead and circle that. This is the rate. For each text you send, the cost is 20 cents. Ooh, okay, so I realized this is actually not the rate because they charge you $30 a flat rate. It is technically a rate, but it's not the slope. This is just a flat fee. The real slope here is going to be each text you send. Now, I don't know if you guys actually understand that we used to live in a world where texting was not free, and texting used to cost per text, right? A certain amount of money per text. If X represents the number of texts you send and Y represents the total monthly bill, write an equation that represents the situation. Okay, so again, let's do a recap of our slope-intercept form, right? This case, this could be the fee, the monthly plan cost, no matter what. And then this is going to be your text cost, right? Each text you send increases your monthly fee. So for that reason, I know that it's 0.20x plus 30 as my monthly bill. Okay. Later on, you'll realize that, let's say, oh, Mr. Kuo has $50 to spend on his cell phone bill per month. How many texts can he send at maximum, right? So you utilize linear equations more often than you think. I think a lot of times when we're calculating things, we don't realize that we live in a world where linear rates are very, very common. Okay. Now we're going to dive into this world of taking an equation and converting it into slope-intercept form. You can make the argument that what we're doing now is a little bit of module 1, right? We're trying to isolate y. Remember in module 1 where all we did was isolate the variable x? Well, in this case, what our number one objective is to isolate y, right? Why are we isolating y? Because isolating y means that you will have something that looks like this. And when you have an isolated y and everything else is on the right side of it, that means you have the answer in slope-intercept form. Okay, so if you take a look at number 8, you'll realize that we have x on the left side, we have y on the right side, and y also has a coefficient that's a variable. I mean, not a coefficient that's a fraction, not a variable. But in this case, I kind of want to get rid of that 1/3 as my first step. So utilizing the strategies we learned in module 1, do we all see that I can first multiply the entire equation by 3, right? That way it will get rid of my fraction in front of the y. Okay, you're going to have to be very, very careful here. You want to make sure you're accurate. You get 42 minus 3x is equal to y minus 6. Okay, so now we can see that the y is on the right side. All we really have to do is just add 6 to both sides. And then I'm going to rewrite my equation with the y on the left side. This is typical behavior for any mathematician. Whenever you solve for a variable, you can always just rewrite your equation with y being on the left side, right? I realize that this is going to be a 0, and 42 plus 6 is 48. Now, I don't want to say 48 first. I actually still want to write the negative 3x first, because that will make sure the reader knows that this is the slope. Okay, so you could put the negative 3x in the front like I did, and I prefer that you do that. 42 plus 6 is therefore 48, and then box your answer. Every time you do your homework this module, you need to show me work. You need to show me the steps. This is something where if you practice it often, you will improve your accuracy and your speed. Your slope here in this case is negative 3. Your y-intercept, your b value, again, sometimes you can just write 48. I think 48 is fine. You could also write it as 0, 48 if you want to be super fancy in coordinate point form. Okay, I hope that was easy for you. Moving right along. Okay, we talked about this in the last module. When you have a negative for your fraction in front of your fraction, I would suggest to always place the negative in the numerator. In or on, let's just write on the numerator, right? So because this allows you to really dictate where the negative is, and then when you cross multiply, you don't forget. Okay, so I'm going to rewrite this again. Y minus 5 over x plus 8 is equal to negative 1 over 2. You're like, wow, Mr. Kuo, did I really have to rewrite that? Well, I think you did. And now I'm going to do what we always do when we have a fraction equaling a fraction. You want to cross multiply. right? Again, our goal is to isolate y. Our goal is to get y by itself. So I'm going to cross multiply here, and I end up getting 2 times y, which is 2y, 2 times negative 5, which is negative 10, is equal to, this is a negative now, and you have to distribute to both of these terms, negative x minus 8. Got to be really, really careful. Recap. 2 times y, 2y. 2 times negative 5, negative 10. Negative 1 times x, negative x. Negative 1 times 8, negative 8. Okay? Now, our goal is to isolate y, so you always want to get rid of a constant. Whatever constants that are next to your y variable, you should always get rid of as your first step. This creates a zero pair, and this creates a positive result. 2y is going to equal negative x plus 2. Okay, so now I'm one step away. All I'm going to do is divide both sides of the equation by 2. Now, this is actually a negative 1x, right? So really, negative 1 divided by 2 is negative 1 half, right? So this ends up being, I like to write my slope out. Some people can leave it as x over 2. They prefer to leave it as x over 2. I am not one of those people. I like to write it like this, negative 1 half x plus 1. The reason why I do it like that is because it's very, very obvious what the slope is. It's negative 1 half. And then your y-intercept is 0, 1. All right. That was a great question. We cross multiplied. You can see how cross multiplying is within almost all of the modules we've done so far this year. Okay. Number 10, a decimal question. You knew a decimal question was coming up. I hope you all realize how obvious the first step should be. We all have a decimal, so we might as well just clear the decimal, right? Multiply the entire equation by 10. Now, a reminder, you are only allowed to do this for equations. You can't really do this for just random expressions because an equation is a scale, right? So if you do it to both sides, that makes it even. If you didn't have the equation or an inequality for that matter, you can't just multiply by 10 randomly because then that means you're making it larger, and then eventually you'd have to divide by 10 if you wanted to do that. Okay, but let's just get to it. 2x minus 5y is going to equal 1, 6, which is 16. Okay, so our goal is to isolate y, right? And this is potentially a step that you may not be totally comfortable with, but you know what? Let's just do it. We know that we can always get rid of the 2x by doing what? Subtracting 2x. I realize we did this in module 1 too, right? It's when you solve a variable and you isolate a variable when other variables are in the same equation. So this ends up being negative 5y is going to equal, now I like to put the negative 2x in the front. You can put 16 minus 2x, but I like to put negative 2x in the front and then just add 16, right? Technically, this is a negative 2x and this is plus 16. So according to the commutative property of addition, we can always alternate the location of the x value. I like to keep it in the front. I prefer you to keep it in the front as well because that's how slope-intercept form is written. Now, I'm going to divide both sides by negative 5, and this is where you have to be very, very careful. That was a negative because I wanted to get rid of the negative. So these cancel. I get y is equal to negative 2 divided by negative 5 is just a positive 2/5 x. And then 16 divided by negative 5 is just literally negative 16 over 5. You should just keep it as an improper fraction. Some people can change that to 3.2 because 16 divided by 5 is 3.2. But I would prefer to keep it as a fraction. Your y-intercept here is going to be 0, negative 16/5. Put a star next to this one, number 10. I like this one a lot. All right, how are we doing? Let's take a break from here. Let's see how we feel, and let's take a break.